Ever wondered what HTTP request headers are and why they matter? Well, let's embark on a fascinating journey into the world of web development and unravel the mystery of HTTP request headers. HTTP request headers are like the unsung heroes of every web interaction. They're key value pairs sent by the client, typically a web browser, to the server as part of an HTTP request. But what do they really do, you ask? They play a crucial role in providing additional information about the request. This information includes the client's capabilities, preferences, and even metadata. Think of these headers as the backstage crew of a theater production. They might not be in the limelight, but without them, the show wouldn't go on smoothly. They ensure that the web server understands exactly what the client is asking for, how it can process the request, and how to tailor the response to best suit the client's needs. For instance, some headers specify the domain name of the server being requested, the type and version of the browser making the request, or the media types that the client can understand. Other headers indicate the preferred language of the client, the request's content type, or the size of the request body. They can even provide the URL of the page from which the client navigated to the current page. HTTP request headers are the unsung heroes that keep the web running smoothly, ensuring that your web browsing experience is seamless. They are the silent negotiators between your browser and the server, shaping your online interactions by providing the server with the information it needs to deliver a personalized, efficient, and secure response. So next time you hit that enter key after typing in a URL, take a moment to appreciate the work of these invisible HTTP request headers. They're quietly working behind the scenes to make your web experience as smooth as silk. Now that you know what HTTP request headers are, let's delve into each of them. Starting with the host header, it specifies the domain name of the server being requested. This could look something like host www.example.com. It's essential because it allows a single server to host multiple websites. Next, we have the user agent header. This one tells the server about the client making the request. It includes details like the browser type, version, and operating system. An example might be User Agent Mozilla 5.0, Windows NT 6.1, WoW 64, RV 12.0, Gecko 201001001, Firefox 12.0. It's like the client's ID card, allowing the server to tailor the response based on the client's capabilities. Think of it like a restaurant modifying its menu based on a customer's dietary requirements. So, in a nutshell, while the host header helps the server know who it's catering to, the user agent header gives insight into the client's characteristics. So these headers provide crucial information about the server and the client. Moving on to the accept headers, they indicate the media types, languages, and encoding methods the client can understand. The accept header is like a restaurant menu for the client. It's a way for the client to say, "Here's what I can digest, please serve me accordingly." For example, if the client prefers images in the JPEG format, it may send an accept header with the value image JPEG. This prompts the server to return images in this format if available. Now let's talk about the accept language header. This header is used when a client has a preference for content in a certain language. So if you're browsing a website in France, your browser might send an accept language header with the value FR, telling the server it prefers content in French. The server, being the good host it is, will then try to serve content in French if it can. Lastly, there's the accept encoding header. This one is all about how the data is packaged. The client uses this header to tell the server which encoding methods it can decipher. For instance, if the client can handle zip compression, it might include zip in the accept encoding header. The server can then compress the response using gzip, which can significantly speed up data transfer by reducing the size of the response. In a nutshell, these accept headers are the client's way of saying, "This is what I can understand, this is the language I prefer, and this is how I'd like the data packaged." They work together to shape the server's response, ensuring it aligns with the client's capabilities and preferences. These headers are not only crucial for creating a smooth user experience, but they also contribute to the efficient and effective operation of the web. They allow clients and servers to communicate with each other, facilitating the seamless exchange of information that we often take for granted when we browse the web. So next time you're browsing your favorite website or working on your web development project, remember the role these headers play. They're the silent negotiators, ensuring that the data you receive is in a format, language, and encoding that your browser can handle. These headers ensure the server's response aligns with the client's capabilities and preferences. Next up are connection, content type, and content length headers, which manage the connection and content details. Let's start with the connection header. This header specifies whether the client wants to keep the connection open for further requests or close it after receiving the response. For example, a connection header value of keep alive suggests that the client wishes to keep the connection open, enabling multiple requests to be sent over the same connection. On the other hand, a value of close means the client prefers to close the connection after the current request and response are finished. Next, we have the content type header. This header is used to specify the MIME type of the request body sent by the client. MIME, standing for Multipurpose Internet Mail Extensions, is a way of identifying files on the internet according to their nature and format. For instance, using application JSON as a content type header value means that the request body is in JSON format. Other common MIME types include multipart/form data for file uploads and application/xww form URL encoded for form data. Finally, there's the content length header. This header indicates the size of the request body in bytes. It's particularly important when the request contains a body, such as in POST or PUT requests. By specifying the size of the body, it helps the server determine the end of the request body when reading from the input stream. This ensures that the server reads the entire body, no more and no less. To sum up, the connection header manages the connection status between the client and the server. The content type header specifies the format of the request body, and the content length header indicates the size of the request body. These headers play a crucial role in facilitating effective communication between the client and the server, ensuring that the data sent is accurately received and interpreted. These headers help control the connection status and handle the request body effectively. Last but not least, let's talk about referrer, cookie, authorization, and cache control headers. The referrer header takes center stage first. This header provides the URL of the referring page, the one from which the client navigated to the current page. It's like leaving a trail of breadcrumbs behind, helping the server trace back the source of the request. An example? Sure, consider a scenario where you click on a link on a web page to navigate to another page. The URL of the initial web page is sent in the referrer header. Next in line we have the cookie header. This little helper contains any cookies previously sent by the server to the client. Cookies are used for maintaining state between HTTP requests and managing sessions. They're like tiny tokens of memory, remembering your actions and settings, so you don't have to re-enter them every time you visit a site. Moving forward, we touch on the authorization header. This header specifies the authentication credentials, like username and password, needed to access protected resources on the server. It's like a bouncer at a club, not letting you in unless you have the right credentials. Lastly, the cache control header steps into the spotlight. This header specifies caching directives to control caching behavior in both the client and intermediary caches. Directives include no cache, max age, public, and private. Think of it as a manager, controlling what gets stored and for how long, aiming to optimize performance and reduce bandwidth usage. In conclusion, these headers, referrer, cookie, authorization, and cache control, play a significant role in the HTTP request process. They maintain state, secure resources, and optimize performance. They're the backstage crew of the web, working silently to ensure a smooth and efficient browsing experience. These headers play a vital role in maintaining state, securing resources, and optimizing performance. Now that you've learned about the different HTTP request headers, you can see how they contribute to a robust and secure web application. You've dipped into the significance of headers like host, which specifies the server's domain name, and user agent, which provides insight into the client's capabilities. You've understood the role of accept headers and their variations, which indicate what the client expects in terms of media types, language, and encoding. You've also seen how connection, content type, and content length headers control the interaction between the client and server. And we've covered the importance of referrer, cookie, authorization, and cache control headers, which manage navigation, session state, access permissions, and caching behavior respectively. It's clear that each header has a unique purpose, and together they form a comprehensive picture of the client's needs and preferences. Remember, understanding and appropriately handling request headers is essential for building robust and secure web applications. Thanks for watching.